Section R.4, slope and linear functions. So what do we have here in this section? Because it talks about slopes, let's define what a slope is. A slope, if I pick on the xy plane, we have xy plane, and we choose two random points, call it x1, y1, x2, y2, like so. Connect them together. So this is a line, connects these 2 points. This line has a slope. It's going up from the first point up, so this expect to be a positive slope. We define the slope if I draw a horizontal line and a vertical line. This is called rise and run. So slope by definition is rise over run. So what's the rise? So if you drop this one, that's an x1. This is x2. This is y1. This is y2. So the rise is the change in the y's. Change in x. Change in y, which is this vertical distance here, that one I'm highlighting. That's going to be this whole thing, which is y2, minus this piece, which is y1. So it's y2 minus y1. Same thing for this. This is x2 minus x1. x2 minus x1. That's what the slope is. To apply it, let's look at an example. So we might ask to find the slope of the line containing, let's take the first set of points, 2, 5 and 1, 3. Then we can look at another example, -1, 5 and -2, 2. 2, 7 and 3, 7. Let's look at the first one. How do we do this? You can label them if you like, x1, y1, x2, y2, and write down the slope formula. We usually use m for the slope, which is y2 minus y1 over x2 minus x1. Well, y2 is 3, y1 is 5, x2 is 1, and the other one is 2. So -2 over -1, which is +2. For this one, the slope would be y2 minus y1, x2 minus x1. So on the top I get -3, -2 plus 1, -3 over -1, that's a +3. So that both of them are positive slopes. So that tells you the line's going up this way. If it's negative, the line goes down. For this one, y2 minus y1, x2 minus x1. That gives us 0 over 1, which is 0. So 0 over a number is going to be 0. And 0 tells me it's a horizontal straight line, like this. Horizontal line has no slope, neither going up nor down. 5, 3, 5, 11. The slope would be y2 minus y1 over x2 minus x1. That gives us 8 over 0. Oh, we can't divide by 0. So this is called undefined slope. And this means the line is going to be a vertical line. That's what undefined slope or not defined slope. Now, sometimes they can give you a diagram, a figure like this, and they say 2.5, 3.5, and they ask you to find the slope. Find the slope for this line. Well, remember, the slope is defined as rise over run. Rise over run. What's the rise? 2.5, run 3.5. So what you need to do here is you can multiply top and bottom by 10 to get to decimal points. When you multiply by 10, it cleans up the decimal point. If you divide by 5, both top and bottom are divisible by 5, you get 5/7. That's bigger than 0, so it's a positive slope, as you can see. So slopes has lots of applications in real life. But the first thing, before we check applications, we need to see first, talk about equations of the straight line. So to work with equations of straight line or linear functions or linear straight lines, so linear functions is any function in the form y equals mx plus b, or the other form, important to get used to it, is f of x equals mx plus b, mx plus b. So m here is the slope that we were talking about earlier, and b is called the y-intercept. Y-intercept means where the graph crosses the y-axis, where the graph crosses the y-axis. So if we have a line like this, always x, y, I label everything, and let's call this 2. This is -1, let's say. The b for this line is 2. That's where it intersects the y-axis. The slope is rise over run. Let's say you want to start at one of the points. Say I want to start at A. So A, you go up 2 units. So up 2 means positive. To the right, 1 unit. 1. So the answer is 2. If you go down, it's negative. To the left, negative. So left and down, those are negatives. Up to the right, those are positive. Those are positive. And that form, as a note, y equals mx plus b, is called slope-intercept form. Slope-intercept form. So first thing, if they ask us, maybe they ask us not just on the graph, find the slope and the y-intercept. For each of the following, let's say 3x minus 4y minus 2 equals to 0. We need to find the slope and the y-intercept. So to do that, I need to solve for y. I want to get y by itself. How do I get y by itself? Subtract 3x on both sides and add 2 to both sides. So you get -4y equals -3x plus 2. Then divide everything by -4. What do we get? Y equals 3/4 x minus 1/2. So slope, which is m, is 3/4. That's the slope. The y-intercept, b, is -1/2. Another one, 2x plus 3y equals to 0. We need to find the slope and the y-intercept. So how do you do that? We subtract 2x on both sides. I want to get y by itself. So 3y is -2x plus 0. Then divide both sides by 3. So what does that give us? Y equals -2/3 x plus nothing, so plus 0. means the slope is negative 2/3 and the y-intercept is 0. Another application to this, you can be asked to find an equation of the line with slope 3 and containing the point -2, -5. Well, first thing I would do, I would write down the formula, the mx plus b. They give me the slope 3, so I can go ahead and replace m with 3. To finish solving or finding the equation, we need to find b. How do I find b? Okay, how do we find b? Well, to do so, there's a point given. That point has coordinates x and y. It's on the line because it says it's containing. So the point is somewhere on the line. This means the x and the y coordinates satisfy the equation. So we can replace y with -3 and x with -2 plus b. -5 equals -6 plus b. Add 6 to both sides. You get 1 equals b. So we found b equals 1. Substitute it back in there to get y equals 3x plus 1. That's the equation. Now, there's another way to think about this. It's called point-slope form. And you may use either one of them on a quiz, test, homework, anything. Slope point equation of a straight line is given by y minus y1 equals the slope times x minus x1, where m is the slope and x1, y1 is the point. So if they ask us to do the same problem, the slope was 3 and the point -2, -5, we can use this formula instead of the previous formula. Let's see what we get. Y minus y1, -5. Slope is 3. X minus x1 is -2. We have to simplify. Negative is positive. 3 times x, negative is positive 2. Then multiply by 3. You get 3x plus 6. Subtract 5 on both sides because I want to get y by itself. So that gives me 3x plus 1. 3x plus 1. So we get the same answer as the previous example. Or you may be asked to find the equation of the line. Find the equation of the line containing the points -1, 3, and 2, 6. Well, what we can do, we can find the slope first by using the formula for the slope, y2 minus y1 over x2 minus x1. Always label the points, x1, y1, x2, y2. What do we get for this? y2 is 6, y1 is 3, x2 is 2 minus -1. That's a 3 over 2 plus that's a 1. So I found the slope, but I don't have the y-intercept. So what am I going to do? If I want to use the formula, y minus y1 equals m times x minus x1. You may use any of the two given points. You can use either the first one or the last one. So let's use the first one. y1 is 3. The slope is 1. x1 is -1. So this stays the same. 1 is nothing, so x plus 1. Then add 3 to both sides. Now notice The slope here is 1 and the y-intercept is 4. How about applications? Some applications to this. One of the applications that we use slopes for that is in the business applications, where it talks about revenue, profit, loss, things like that. So how do we apply these things? First thing is always the cost function. We use C of X for that. That's the total cost. So total cost function is always equals the variable cost plus the fixed cost, where X number of items, let's say, or producing items. So let's say, for example, you take a taxi to the airport and they tell you the first thing we need to do is we need to find first, or the taxi tells you we charge you $3 to start with before I actually, at the minute I pick you up from your home, and then it would be 20 cents per mile. So 20 cents per mile, and there's a $3 charge to start with. So then what would be the cost? Say there's an X number of miles. Then the total cost, C of X, would be the variable cost is 20 cents times the number of miles. In dollars, that's 0.20x, because I want to get everything in dollars, plus the fixed cost, which is the $3. So that gives us the cost function. Now, can we graph this? Yeah, to graph it, so we look at it as y equals 0.20x plus 3. And there's so many ways to graph this. First method is you can pick values for x. So say x is 0, y would be 0 plus 3, 3. X is, you can pick any number, 10, 1, 1. Y would be 0.2 plus 3, which is 3.2. We have 0, 3, 1, 2, 3. And the next point, so this is a point 0, comma 3. The next point is 1, comma 3.2. So 1, comma, a little bit up here. So notice what I did. This is x. X is the number of miles. It's not going to be in the negative. So that's why probably you can get rid of that part like that. So this is the graph of this. Or another way to graph this, if you have decimals, you can change it 2 over 10, right? That's what 0.2 is. But you can reduce this 1 over 5x, you divide by 2. And now when you want to graph it, you start at 3. 1, 2, and 3. That's the y-intercept. And then this is rise. Rise is 1, so you're going to go up 1. And 5 to the right, that's the run. 1, 2, 3, 4, 5. Should be the same as the first one. Rise over run. So if it's positive 1, you go up. Negative, you go down. The 5, it's positive, you go to the right. If it's negative, you go to the left. Other good terms to know is the revenue. what is revenue or total revenue? So to find the total revenue, this is going to be always, you take the number of items sold times the price paid per item. Price paid per item. So we usually use capital R of X. So we call it the unit price times the quantity sold. This is called revenue or total revenue. From this and the cost, we get the total profit. How do you find total profit? We call it P of X. It's always the total revenue. So how much you paid for the items minus the total cost. So that would be P of X equals the revenue R of X and the cost is C of X. That's the formula for the profit. Good thing to know as a note, we call it break-even value. This occurs when the revenue is the same as the cost, so you make no profit. This means the profit is 0. So if you're asked to find the break-even value of, let's say, X or something, they are asking you what are the X values where R of X and C of X are equal, and you will have an equation there and be able to solve it. These are terms that we use here as application to slopes and straight lines. If in case you come across an example or problem on the homework asking you to find the slope of the line containing 2 points and one of them has fractions, it's okay. It's okay to work this out. So for example, let's say 1/4, 5 and -3/4, 5/4, let's say. It's fine. So to find the slope, it's y2 minus y1 over x2 minus x1. This is over 1. Multiply by 4 and 4. So that gives us 5 minus 20/4. And here -4/4, the common denominator. On the top we get -15. The 4's cancel over -4. So how did I cancel the 4's? Because you can multiply this fraction by 4 and the bottom by 4. You can multiply the top of each fraction by any number you like. So what do we get here? The negatives cancel, it becomes 15/4. That's the slope of the line.